WaveNet and CycleGAN are two cutting-edge machine learning techniques that have revolutionized the way we generate and transform audio and images. WaveNet excels at generating high-quality and natural-sounding speech and music, while CycleGAN is a powerful tool for image-to-image translation, enabling the transformation of one type of image into another, such as converting photos into artistic styles or creating cartoon version of real-life people. So this video will delve into the inner workings of these fascinating techniques and will explore their numerous applications in various fields. So let's get started with what is WaveNet. Basically, WaveNet is a deep neural network architecture used for generating and processing audio signals such as speech and music. It is based on the type of recurrent neural network called a convolutional neural network, which is particularly suited for processing sequential data. The main innovation of WaveNet is the use of stack of dilated convolutions, which allow the network to learn long-range dependencies in the audio signal while maintaining computational efficiencies. Dilated convolutions are a type of convolution operation where the stride of convolution is increased by the factor of dilation rate, allowing the network to skip some of the time steps in the input signal while still analyzing the entire signal. Another key feature of WaveNet is the use of skip connections, which allows information to flow directly from earlier layers of the network to the later layers. And this helps to preserve the temporal coherence of the signal and ensures that the network can learn complex patterns at different time scale. To understand how WaveNet works, let's consider a simple real-life example. Imagine you are a music composer who wants to generate a new song based on a particular style. You have a set of audio clips from songs in the style and you want to use WaveNet to learn the underlying patterns and characteristics of the music so that you can generate new songs that are similar in style. Now the input to the WaveNet model would be an audio clips and the output would be a set of features or characteristics that describes the music. For example, the features might include the spectral characteristics of the audio, say the distribution of frequencies, the tempo and the rhythm. So to generate a new song, you would provide the WaveNet model with a set of initial conditions, that is temporal and a set of initial chords, and the model would generate a sequence of musical notes that are consistent with the learned style. So you could then use this generated sequence as a starting point for further creative works. So in this way, WaveNet can be used as a tool for generating music in a particular style while still allowing for creative input and modification from the composer. So next, understand what CycleGAN. CycleGAN is a type of generative adversarial network used for unsupervised image-to-image translation. It learns to transform images from one domain to another, such as translating a photo of a city into painting style image without any labeled example of paired images in the target domain. CycleGAN consists of two GANs, a generator network and a discriminator network. The generator network takes images from one domain as input and generates images in the target domain. The discriminator network distinguishes between the generated image and real images from the target domain. So to ensure that generator produce diverse and high quality results, CycleGAN architecture also includes a cycle consistency loss. Now this cycle consistency loss encourages the generator to produce images that when transformed back to the original domain by the generator are similar to the original input images, and this constraint ensures the generator does not overfit to a specific style or structure and instead learns a more general mapping between the two domains. So to summarize this, we can say CycleGAN is a powerful technique for image to image translation which learns to transform images from one domain to another, and it achieves this by combining GANs with a cycle consistency loss to ensure high quality and diverse results. To understand it better, a simple real life example of CycleGAN in action is transforming a photo of person's face into the cartoon version of themselves. So let us say we have a data set of photos of people and a data set of cartoon style character illustration. And our goal is to create a CycleGAN that can transform any photo of a person's face into the cartoon style illustration. Here the CycleGAN would learn the mapping between the two domains from the photos to the cartoon style illustration and vice versa. And this mapping would allow the generator to take a photo of the person and produce a cartoon style illustration of the same person. To ensure the generated illustration are diverse and maintain the essence of original photo, CycleGAN cycle consistency loss would ensure that transforming the generated cartoon style illustration back into the photo style image would result in an image that closely resembles the original photo. So in this example, CycleGAN would learn to capture the essential features and characteristics of the person's face, such as facial structure, hair and eyes, and will translate them into a cartoon style illustration. So with this simple example, you can see how CycleGAN can be applied to generate creative and visually appealing results. Thank you.